Today we're going to talk about the position Q block, but first we're going to do an example application where you might use it, then show the code. Alright, to explain why position Qs are great and why you might want to consider them, I'm going to use the illustration here on this page. This illustration is of a rejection line. It's a type drop conveyor. Most of you guys know what a drop conveyor is or a rejection line, but for those who don't, I'm going to describe it shortly here. The goal of a rejection line is basically put the good stuff on a good conveyor, put the bad stuff on a bad conveyor, or bucket, or garbage, or incinerator. Doesn't really matter. It just gets rid of it, right? And they all have some method of doing it. The drop conveyor uses a pivoting conveyor called the drop conveyor. As you see here, it's the tilted one. It moves up and down and pivots here. That's how it gets rid of the bad stuff. And if you do your code right, the good stuff and the bad stuff go to the appropriate spots. And if you're lucky, which I'm never lucky, they're going to stick the sensor right here in front of the conveyor. So all your code has to do is read the box and say, look, this is a good box or a bad box, and it puts it where it needs to be. But if you're like me, you're never going to see it right there. You're going to have it way down over here. And I don't know why this is. It could be mechanical reasons. They couldn't put it any closer. Maybe there's a process between. I don't know. Maybe they don't like you. Maybe they just want to see you squirm. It doesn't really matter. The thing is, they always put it far away. And as a programmer, you have to deal with this, right? And what do we got to deal with? We got to deal with all of the boxes between the sensor and the rejection line. So in this case, we got 4 of them. And if you're really lucky, that sensor is going to be really far away, like 32 feet. So how do we go about this? One way is to use timers. A lot of people love timers. Everyone knows how they work. It's not the best fit for this application, but I'm going to show you just so you can get an idea of why position Qs are great. If you're going to use a timer, you're going to need a delay timer. The delay timer is going to be a delay between when the sensor here knows it's a bad box or a good box, right? In the case of a down, it would be a bad box because the conveyor is going down. Then you're going to need a delay timer for when it goes up. Simple enough, right? Well, it gets a little bit more complicated here. The problems are, if the speed changes, none of it works. So if you don't have great speed control, you're not going to hit your mark. If the user decides that it's running too fast or too slow and he changes the speed, your code has to calculate speed to distance, which means more work for you. In the previous slide, I was showing you that you needed 2 timers. Well, here we got 4 boxes. So that's really, you need 2 timers per box. And as you can see, the more boxes you have, the more sets of timers you're going to need, because technically they could all be rejection, they could all not be rejection, they could be every other one's a rejection. And you're going to need sets of timers to deal with it. The worst part about this is anytime the system has to stop. Someone hits an e-stop or a pull cord, or they just stop it because of maintenance, whatever. All of the boxes between the sensor and the rejection point are now lost. The system doesn't know what to do with them, and what you end up finding is people have to come over, unload all the bad boxes off, or whatever on it the next startup. Here's the second option. Use a position Q. What do you need? You need 1 Q for the index down. You need 1 Q for the index up. You need to know the distance between the sensor and the drop point, which is a lot nicer than, dealing with speeds. You just say, hey, Mr. Q, it's this distance away, and it takes care of it for you. Some people like to also use the size of the box. This is not required, and I would suggest trying to write it so that you don't need it. For example, you could use 1 Q, see this Q right here, it's an index up, right? Oh, sorry, index down, for all the bad boxes. And use the index up for all the good boxes. In doing so, it limits the number of times this rejection conveyor has to move and will work regardless of the size of the box. Problems that you have here is the queue has to be able to hold the number of boxes in it. So if you have a queue that only holds 5 data points, you can only do 5 boxes with that queue. But queues are pretty flexible. Unlike timers where you have to keep adding more timers, most queues you tweak the code a little bit, or it's a setting or whatever, and you instantly get more boxes. For example, thousands of boxes can be queued up without problems, without making the code any bigger. It just handles them. So the benefits are smaller code. You can change speed without any problems at all. I mean, without any, because it's keeping track of position. And you can even stop it, run it backwards, then run it back forward, and if you designed your queue system right, it will still put the boxes in the appropriate locations. Pretty cool. Alright, so here's my example code. You can see there's not a lot here, but it doesn't technically take a lot to do that application I was showing you with the rejection line. Of course, you'll need a little bit more than this, but for a bare bones example, this should get a pretty good concept of what's going on. So what I have is I have 2 digital inputs. I have digital input 2. That says it's a good box. I got digital input 6. It says it's a bad box. This is mostly so I have control of what the logic's doing, right? And then this queue here is for the good box. This one's for the bad. And then on the bottom, again, for the good and the bad. And what happens here is when we get a good box, this input turns on, which says take this data and this system position, that's the actual position it is, put it in the queue such that when the box moves 10,000 millimeters or whatever this unit is, that this output turns on for one scan. Okay, now this little output I keep pointing to basically tells you how much is left. So if I was to turn this on, you can see that there's a distance of 10,000 there. And if I move the motor just slowly with my hand, whoops, it's not moving. You know why? I didn't enable the position queue. Alright. There, so it's enabled. Alright. Okay. So as you can see, it emptied out. Alright. As you can see, that was changing. So let's run through this. So what I have here is the position. This is the actual position of the master, or the actual motor. This is this guy's countdown. This is this guy's countdown. And this one here is this decision whether to index up or to not index up. So if it's a false, we're going to say it's a reject. Okay. So I'm going to start off. I'm turning the motor here. And we get a good box, right? You can see it's counting down. I am turning this with my hand. As you can see, if I turn it backwards, the position counts up because it's going further away from its target, right? So you go back this way, counts back down. Alright. And now I'm going to have a bad box. Watch, bad box come through. Right, so it's counting down, and here we go. Let's turn this a little faster. Alright, now as you can see, this was already up because it was already, last box was also good. Okay, so we get another good box, we turn it, and now we get another good box. You can see it's holding 2, another good box. Oh, look, it went false. Got a bad box, good box, bad box. And these little counters just take care of it. So, look. defaults. Back good. And back false. Now, this particular cue block that I'm showing you only holds 5 per box, but like I said, you can usually tweak or edit or whatever. So I'm going to jump in the code here. And if you scroll down here to the bottom here, there's this FIFO. Oh, this is the size of the FIFO. If you want to make it so that it can hold, 500 boxes, there. Now you're done. That's all you have to change, and it now can queue up to 500. If you have any questions, please, type them in the bottom below, and have a good day. If you like this video, please subscribe or put a comment below.